Hi, everyone. You're listening to Bug Talk, a podcast created by members of the Entomology Department at Michigan State University. In today's podcast, we'll be talking to Dr. Julie Lesnik, an associate professor of anthropology at Wayne State University. And today with me, I have a co-host, Ariana.
Hi.
And I'm Jen. And we're here with Julie Lesnik. Hi, Julie. How are you doing today?
I'm good. Thanks for having me.
Yeah, thanks for coming. We really enjoyed your seminar, and are really excited to have you on the podcast. I thought we could start out by maybe you telling us a little bit about yourself, maybe a little bit about where you grew up, how you got started in the field.
Yeah. So let's see. I grew up outside of Chicago in the suburbs, Lockport, Illinois, which is near Joliet. And amazingly, when I was a senior in high school, I was taking AP biology, and my teacher just knew everything. Like any question I asked, he knew the answer to, and I was just blown away. And so I was like, I want to be that knowledgeable. Like I want to know biology, and I was super into biology. I'm like, I want to know biology that well. And I also really liked teaching, but I knew that kids were not my thing. I'm the baby in the family by a lot. I've never babysat ever. And so in thinking about loving biology and wanting to teach in high school, I was like, I want to be a biology professor. So I knew that I wanted a PhD and to be a professor since a pretty early age. Not because I had any professors around me. Like my mom's a nurse, my dad was a PE teacher. And so it was just something that I just fell in love with, and I just wanted to chase that dream. And so I've been reflecting on it a lot because I just got tenure last year. And so it's been this 20-year journey that started in high school, and here I am tenured professor. So it's been a crazy ride to actually choose what I wanted to do at such a young age and see it through. But somewhere along the line, I switched from biology to biological anthropology. I was taking my biology classes, and although I loved it, it was once I started applying it to humans that it just kind of all clicked. And I definitely wanted to study human evolution because I feel like I was just raised in this society that acts like humans are gods and not actual biological beings. And so I wanted to study us as biological beings. And so that's what I went into grad school to do, and how I ultimately got a PhD in bioanthro.
That's super interesting. Congratulations on your tenure. That's exciting.
Thank
Congrats,
you.
yeah.
Thank you. Yeah, it's a very weird thing, during the pandemic, to get tenure, to be up for tenure in the pandemic when everything was so uncertain. I was like, oh my God, I might be the first person they get rid of. I don't know. And then to get it and have no way of celebrating because we're all just alone. So it's been a weird transition, but it's nice to be on this side of it.
Yeah, definitely. Yeah, it's an odd time for everyone, I think. So I think it's kind of important to acknowledge that, we're on an entomology podcast, but you're an anthropologist. But you do have a lot of involvement with insects. Could you talk a little bit about how you got interested in an entomological perspective on anthropology?
Yeah, so in getting into biological anthropology. So biological anthropology is, the study of human evolution. It's a subfield of anthropology more broadly. Anthropology is just the study of humans, and we're so complicated, so you can study us from a million different ways. So although I incorporate a lot of other anthro perspectives, I am primarily a biological anthropologist. And so in wanting to understand humans as biological beings, one of the places I started was getting to know our closest living relative today. So chimpanzees being very closely related to us. And so just in studying them and learning about them, reading about them, realizing that they are amazing tool users. So in learning about chimpanzees, it was always they're amazing tool users. And their brains, they're so smart and they solve problems. And so ancestrally, our ancestors must have been like that. And so I got super into that idea. And that was really what I went into grad school to study, was sort of the origins of tool use in the hominid line. But it wasn't too much longer when I started studying tool use that I started really appreciating what these chimpanzees were using the tools for. and they're foraging for termites. They are sticking tools into termite nests and extracting the termites out. And I was kind of stunned that in the literature, on all of this literature on chimpanzees using tools, very little credit was given to just how amazing of a food resource termites must be in order for them to develop these elaborate, amazing technologies. And so I kind of started picking at that, in my dissertation, started challenging the literature that we already had and started trying to kind of almost give an insect perspective to this aspect of, chimpanzee diet or human diet in a way that nobody really had before. So I started needing to appreciate termite diversity in a way that no paleoanthropologist ever had, right? So people would be like, oh, they were eating termites. And I was like, that's a useless category to me. What nutritionally were they eating? And so I started recognizing how diverse termite taxa were. And all of a sudden that became my job, was to argue that insects are incredibly diverse and we can get a range of nutrients from them depending on which ones we eat.
Yeah, that's really interesting. I know I've always heard about chimpanzees and tool use, and that seems like something that's been super studied. When did people know that it was for termites or, for foraging rather than something else?
Yeah, it was the late 1960s, Jane Goodall.
Okay.
I mean, she was the first one to observe it. And so in her work, so the discovery that chimps use tools was mind-blowing at the time, right? So that launched all our research on this, because the famous quote, so it was Louis Leakey who sent Jane Goodall, to the field to study chimps, because, he had this understanding that, like, if we're going to understand our evolution, we should look at our closest living relatives. And so that was his idea. And then Jane Goodall was the person who went out and forged that path. And so when she reported to him that these chimps use tools, he's like, we either need to redefine human or redefine tool, because we never thought that a non-human would be using tools in this way. And so that is really what launched the research on it, was trying to understand the sort of humanness, or how is tool using different or similar to humans, and how does that help us understand where we came from, and so much less about what they were actually using the tools for.
Right, right. And so there was very little known when you went in the field about what kinds
termites,
right, that they were
Yeah,
eating.
well, we know very well that chimpanzee, we know what termites chimps are eating, and they're super strongly selective. They really only eat termites of the genus Macrotermes across all the sites across Central Africa. And so, the chimp researchers have looked at the nutritional contributions of termites and have looked at what genus. And so it's not like they were ignorant to it or totally ignored it, but those are all just the one-off articles that, if you care, you could go find that information, but that's not the information that began permeating sort of the general thinking of how people think about what chimps are doing with those tools.
Right. Yeah. So how has that information been able, I know a lot of times there's a big misconception about, we evolved from chimps, but it was actually, like you mentioned in your seminar, a common ancestor. How is that information kind of how they forage translated to human evolution?
So yeah, it is. It's a tricky thing, right? So because we look at chimps because they're closely related to us. And so I like to think of it as if we do it and they did it, the simplest explanation is that our last common ancestor did it. But the truth is neither of us resemble that last common ancestor. Both humans and chimps have had 5 to 6 million years of our own independent evolution. But that's what we're trying to reconstruct what it looked like back then. We have to work with the clues we're given. And so something like, oh, we both use tools. They were probably using tools 5 million years ago. Oh, we both eat termites. They were probably eating termites 5 million years ago. So it's just kind of basic logic to get us started. And then we start testing those hypotheses in the hominid fossil record and archaeological record to try to find evidence that supports what we were predicting.
Cool. Yeah.
That's super cool. So during grad school, were you able to travel anywhere to observe the chimpanzees where you were going, or did you just do more wherever your university was?
Yeah, so I got my PhD at the University of Michigan, and I was incredibly lucky that although I didn't do my dissertation on chimpanzees. I'm not a primatologist. I don't study chimpanzees specifically, but I use them as part of kind of a toolkit for what I do. And I was incredibly lucky that in trying to understand I was working specifically to understand tool using in these hominids that are about 2 million years old. And when we reconstruct past environments, we tend to think of the hominid environment in the species that I was working with as sort of being like a mixed savanna landscape, so more open, mixed woodland. And so chimpanzees, when we think about chimpanzees today, they mostly live in really dense forested areas in Central Africa. And so their environments and what they're doing to extract termites from their nests isn't the exact same as what was going on, at least in the sites that, we have information from and the ones I was interested in. It's not the perfect analog. However, we do have a few savanna chimpanzee sites, and these sites are fascinating because they're relatively recently studied, right? So Jane Goodall's site at Gombe Stream National Forest in Tanzania, beautiful dense woodland, dense forest, gallery forest, and so that's sort of where a lot of our knowledge has come from. But there are chimps in these savanna sites that have just been recently habituated in the last handful of years, so the last decade or so, or now I'm getting older, so maybe 2 decades. And so that's the thing, is like with chimpanzees, like in studying any animal behavior, it's a huge endeavor for the researchers to go out, follow them regularly for a year or so, right, to habituate them to the human presence so that we know that their behavior is their natural behavior and not that they're responding to a human. So it takes a long time of habituating the chimps. And so I was super lucky that a site in Senegal, a savanna chimpanzee site, the researcher there, Jill Preetz, had been working on habituating them like leading up to my work. So like by the time I started, she'd been coming up with amazing data from her site. And I just, through connections and networks, was invited to do my dissertation research at her site. So what I was doing is I was making my own experimental tools. Like basically we have bone tools that are almost 2 million years old that preserve wear patterns on the end that suggest they were used to dig into termite mounds. And so that's what launched my dissertation. So that was somebody else's research, but I was interested in, could I see if I could tell different genera of termite mounds, hoping that maybe there's different structure of mound based on who makes them. Because like when I, dig into a Trinervitermes mound, the inside just crumbles. Like it's a really easy, soft inner matrix. But when I dig into a Macrotermes mound, it's like concrete and like hurts my hand. So I was hoping that the different actions might show different sort of percussion patterns on the ends of these tools. So I wanted to go somewhere that had a savanna environment that had multiple genera of termites that would be most similar to what these hominids were experiencing. And what I had available to me in South Africa, where the tools are from, wasn't really great. Like I didn't have access to that diversity that I wanted. So getting to use Senegal as kind of a proxy, I was really lucky. So I just kind of hung out at the chimpanzee site, using my experimental tools, digging into termite mounds. And then I would just kind of go out and visit the chimps and just observe them a little bit, watching them forage for termites, but I wasn't actually collecting data on their behavior.
Yeah, that's super cool. So how long were you at this site at the Savannah?
Man, I was gone overseas for 6 months for my dissertation research, and I split it up. I was 2 months in Senegal and then 2 months at the museum in South Africa where these bone tools were. So I was molding them and getting the actual data on the artifacts. And then I went back to Senegal for 2 months. I was trying to get rainy and dry seasons. So I was trying to leave for 2 months and come back to catch a different season. But of course the rains were late. And like, it's been this funny thing that every time I always try to plan my trips to go see the alates flying. So the alates of the termites will fly when it rains. And it's hard because like our seasons are different and so like I'm usually in school and can't go in the middle of the year when it's raining there. So like every time I'll be like, okay, I'm going for my spring break and I should catch it raining. And of course it doesn't rain. Like I've gone to Africa like 3 times to try to see the alates and have never seen them actually fly. So
I feel like that's always how it works for field work or anything you want to observe. It's just, you want something to happen and the weather's like, sorry.
Yep. Yeah, it makes it feel like a good field researcher, like, when things are the typical, like the typical things that go wrong all the time. When you experience them, you're just like, check, field researcher,
Right.
Yep, it's like science.
Yeah. One of those things is it is actually so I don't consider myself a primatologist, but I always joke because there's a very specific thing that chimpanzees, they love honey, and so they'll go into nests, and then of course they can irritate the bees and the bees can come swarming. And so there is something very specific for field primatologists following chimpanzees, that when you're watching them over there and all of a sudden they turn this way and run, that you just turn and run too, because you know that somebody was messing with a beehive. So I got to experience that. I got to run away from bees that chimps irritated. So I got that badge as well.
I can only imagine how you felt during that.
Yeah.
It's such a funny thing to watch them like spin 180 and start running towards you, right?
So how was it working so up close and personal with chimpanzees? That's not like an opportunity many people, the only time I've seen a chimpanzee is at the zoo, and I can't imagine being so up close and personal with them.
It is. So what an interesting thing about the site in Senegal, it's called Fangoli. Interesting thing about Fangoli is that these chimps, their habitat butts up right next to human habituation. So we try really hard to keep extra distance between us, because we don't want them to become so familiar with humans, because they get like farmers shoot them, right? If they're coming into their fields, they risk, being killed by people that don't want them there. So we tried really hard to keep good distance. I think we were doing 30 yards. So like I was always like had to have my binoculars in order to really see what the chimps were doing. And so that was my first time with chimps, was at that site. And it was even still terrifying. One of the craziest things, so how the chimpanzee kind of field research goes, is that chimpanzees nest at night. So they build nests up in the trees, and that's where they sleep. So when you're a field researcher with them, you follow them all day till they nest, and then you go home and sleep. And then you need to get back there in the morning before they leave so that you don't lose them. And so you're walking in the woods at night at like 4 a.m. to get back to their nesting site. And so when they're waking up, they're vocalizing. Chimps are really loud. And so the first time, like walking in darkness in the forest, hearing chimpanzees like screaming was terrifying. Like I was absolutely terrified. And then you just kind of get used to it. Like, they're not yelling at me. They're not threatening me. They're just loud vocalizers to each other. So that was crazy. But then more recently, I was at Gombe. I was at Jane Goodall's site. And there the chimps, like Jane used to hold them and feed them bananas. And so these chimps are very used to people. We don't do that anymore, mostly because of transmission of disease from chimp to human or human to chimp. Actually, we're more protective of the chimps. We don't want them to get sick. And so we don't get nearly as close as that anymore. But still like 10 feet away, to these chimps. And that was crazy to me, because my first experience was you keep this huge distance. So I always felt very safe. And then at Gombe, they're like right in front of me. And so similar to that sort of, story I said about the bees and needing to pay attention to where they go, is that there is the very much the, like, if the male is displaying. So a lot of times the males just get full of themselves and they hit trees with their hands and they get really loud and they're just trying to display and show everybody that they're tough and work their way up the hierarchy. You duck behind a tree. You keep a tree between you and that male, because you don't want him coming to drum on you, right? You don't want to just kind of be caught in his path. So that was the like skill I had to learn, and you learn it very quickly. Was with the chimps at Gombe, was how to be always aware of what tree I could put between me and the chimps at any moment.
That's amazing. That sounds really exciting and very different from most people's research experiences, I think, in grad school.
Yeah. I'm very lucky.
So I know, as you mentioned, you were studying about kind of like the foraging, the termites, and with what kinds of termites they're eating. How did those results end up, and how did that kind of transition you into your next step in your career?
Yeah, I truthfully, a lot of my work was, So I had this great idea that these bone tools would show the difference between these termite mounds. Basically, there was a lot of advances in microscopy that had just been happening. So I was like, ooh, if I use the confocal microscope, I should be able to do this. And so I had these like high hopes. And truth be told, couldn't tell a difference, right? So that's something I do like to point out to people that, are doing giant research projects or, a master's thesis, honors thesis, dissertation, is like, no results are still results, right? So it's like, I didn't answer the question I set out to, answer, but I got results, and I can write them up and go, hey, you might think this will work, but it won't. It's still publishable. You still need to let people know what you did, what you learned from the process, and maybe the way to go forward. And so no results is still a result. But that was sort of like 1/3 of my dissertation. And since that didn't show what I wanted it to show, I then had to lean just more theoretical reconstructions. And so for the kind of next third of my dissertation, I just did as much literature searching as I can. And the thing I was just trying to figure out, like, what can I say about different genera of termites as food? Who eats what? People and animals, who eats what are they getting out of them nutritionally? And then also, from everything I know about reconstructions of hominid diets, what did they need? Like, what was the missing nutrient in the past that insects could, and termites specifically, could ameliorate? Because in looking across sort of our non-human cousins, their termite preferences very much reflect what their base diet is. So chimpanzees are frugivores, and they eat termites that are incredibly high in protein because their fruit-based diet offers them no protein. They have to get protein from somewhere else. And then gorillas have a leaf-based diet, so they're getting all their leafy greens. There's a lot of protein in that, but they're not eating as much fruit. So they're actually micronutrient deficient. And then the termites they select are the perfect supplement for their diet. So that led me to go, okay, what is the base knowledge I have about what's going on in the past? What is the nutrient I think they would need more of? And then what termite would make most sense for that? And truthfully, it ended up being the easy, obvious answer. So chimpanzees are highly selective for macrotermes, and humans also eat a lot of species of macrotermes. So the answer is macrotermes. But it was a very in-depth, slow slog through all the literature trying to pull that together.
Yeah, that's super interesting. I know part of your talk, you were talking about how women kind of, like, you look at also humans and how they eat different insects in different communities. Obviously, you mentioned not so much, in Western culture, but in other cultures and in the past. Could you talk a little bit about that work?
Yeah, and I think that actually starts with chimpanzees too, in sort of this. So chimpanzee females use tools much more than the males. And so we've always just kind of thought it as being a very tool use specific thing. Basically, the males go off and play, and they need to find their place in the social hierarchy, and they're very gregarious and hanging out with all the males in the group, when females in chimps are actually very solitary. They keep to themselves, and they generally only have their offspring hanging around them. And so they don't socialize with other adult chimps that much. And so we have these two very different behavior patterns. And so the males, since they're kind of busy socializing, they don't stick close to mom as much, and they don't learn the tool using. And it tends to be the adult females. Now we do have, it's cute because you get like the mama's boys too. You get the males that stick closer to mom, and then they become termite fishers. So it's not like black and white. But in general, it tends to be the females that stick closer to mom and learn the termite fishing. So all of the like knowledge of chimpanzee termite fishing was, again, like, yes, it's females, but it was so much about the action of using the tools and so little about what they were getting as a result from using those tools. It was so much more about problem solving and the ingenuity and the social learning and the observational learning. Like, there's amazing knowledge that we have about chimpanzees foraging for termites, but the nutritional contribution was always sort of this like, oh yeah, and this, and so when I started thinking about insects in the hominid diet, it was like, okay, are the hominids females? If they're like, are they the tool users? But truthfully, because we know in the hominid record, our number one thing we have archaeologically are the stone tools and the butchered bones of animals that these stone tools were used. So we tend to be very male centric when we're talking about hominid tool using, because we tend to give men the credit for all the hunting. Now, that comes from correlates of modern foragers. Men tend to go after the larger animals, but women trap game and hunt small animals all the time and can go out in big game hunting parties too. But we have this just gender bias in how we talk about the past. And it comes from the fact that the field's been run by white men for decades, right? So we have these little biases that are just built in, and we take them as assumptions and take them as true. So a major part of my dissertation was the fact that we don't study bugs as food because we have a bias against them. And then we also don't study what women are foraging for that much because we have a bias against them too. And so what I started realizing was, when I started looking at hominids, this sort of female using use the tools more, all of a sudden just disappears when we're talking about hominids. But when I started thinking about females, thinking about Australopithecines, right? So we're more ape-like at that point, roughly 2 million years ago when I studied. And so I'm studying them more like chimps or like gorillas. I'm not studying them like humans. I'm studying them a little bit more, in terms of like how we study animal behavior. And so then all of a sudden it's like, oh, well, females need nutrients to reproduce. Do insects offer the right nutrients for them to reproduce? And it became so clear and obvious, right? Like it became so obvious that females need more protein when they're, pregnant or lactating. They need more protein than even men do. We think that men need more protein than women, but actually pregnant or lactating women need more protein than men. And so we have this narrative that men hunt and bring this meat back to women who need the protein. And I was just like, no, they're not going to sit there and shrivel up and die waiting for men to bring them food, right? Women are out there foraging. And then if you look at termites, they're getting the exact nutrients in termites in something that's not going to hurt them, right? They can sit there. They're there in millions. You come up to a termite mound and there's just millions of these individuals in there, right? So yeah, what's going on is that the women were really smart and getting termites instead of chasing the antelope that they were likely going to not catch. So it's just like a spin in narrative to kind of overcome the biases that we've been placing in sort of our base understanding of human evolution.
Yeah, that's super
awesome.
Interesting.
So what was your next step then after you finished up your PhD? Where'd you go next?
So I finished my dissertation. I graduated in 2011. And I was a paleoanthropologist and I studied past diet. I then had 3 years where I was adjunct teaching. So my research was I wasn't going to the field anymore. I didn't have time or money to go back to Africa and continue any research. And that's actually when I came up with the idea to write a book. Actually, it was a mentor of mine said, you should write a book. And so I was like, oh, maybe. And so that's where Edible Insects and Human Evolution was born. My book that ultimately came out in 2018, I started pitching it to publishers 2012, right? Roughly around 2012. And I knew that this women narrative, that's really what I was pitching to publishers. This sort of like, if you start looking at insects as food, you start looking at foraging. And if you start looking at foraging, you start seeing women. And when you start seeing women, you have a more complete understanding of human evolution. So that was sort of the pitch of my book. So I got a contract to write the book. And that was, I think, very early 2013 when I got the contract. And then May of 2013, the UN came out with a statement. The United Nations Food and Agriculture Organization came out with a statement being like, humans should be eating bugs. We should all be eating more insects. It's going to save the world. like the headlines were ridiculous. It's going to solve world hunger. It's going to solve climate change. Like it was these huge claims. And it was at that moment I was like, wow, I know a lot more about insect eating than most people. I just spent 6 years of my life researching termites as food. And I knew that there were people out there suggesting insects would be a sustainable food. But clearly that's a huge obstacle, like a huge hump for us to get over before that became a thing. So I just kind of ignored it. Like at some points you have to make cutoffs. So like when you're doing a dissertation, you can't do it all. You have to ask small testable questions and you need to finish. And so modern insect consumption for sustainable, sustainable future was not anything I was at all interested in. Up until this point. So when the UN came out with that statement, I was like, wow, I know a lot. And so then I started talking to this community, right? There was a conference up in Montreal in 2014 about insects as food. And so that's when I met my first cricket farmers, as I showed up there and I did a talk on edible insects and human evolution. Was just so amazed by these people. I have, from my undergrad, I have an environmental studies minor. And so sustainability and such has always been something I cared about, but it was my minor, not my major. And so then all of a sudden I'm with these people who like want to save the earth and want to farm crickets and change America, and all, like, just the energy was crazy and amazing. And I just knew I found my people. And so then in 2016, I had them all come to Detroit. And I held an even bigger conference in 2016. Eating Insects Detroit is what we called it. And I had 200 people here, all at a conference just for specifically studying insects as food. And so that everything changed then. Once I was in this community, I became the anthropologist, right? So I used to be a my identity was so much paleoanthropology. But as soon as I'm walking around in these circles, I'm the anthropologist. I'm the one who can talk about ethnocentrism. Like Anthropology 101, the first thing we teach is that we all look at other cultures based on our own values. Like we judge them based on what we do ourselves. So when you're an anthropologist, you train really hard to recognize that and overcome it, because you don't want to bias it. Now, we're human, and so there's a ton of bias in our literature, as I was just mentioning with paleo, but it's something that we're at least aware of and try to overcome, and the best anthropologists are going to be best at that. And so that started being the conversations I had more. Conversations that I'd hear people talk about, the reason we don't eat insects in Western culture is because of agriculture. And I was like, everybody's agricultural. That makes no sense. And so then I had to start studying why we don't eat insects in Western culture, because I was the only one who had any knowledge of like the history of agriculture and human food consumption and how we make our food choices. And so it just made me a much broader anthropologist than I've always loved anthro broadly, but you get so, like, the point of a dissertation is to become an expert on a singular topic. So you get so focused. So I was so focused on paleo. And then it was just this amazing kind of confluence of events that at the right time, the UN statement came out right when I was kind of going on the job market and trying to write a book. And then I became one of the loudest voices for promoting insects, that exists here in the US.
That's so exciting. Who knew there were so many people passionate about this, all along? What are your thoughts on that, about eating insects, and like, is it going to save the world? Is it going to feed the world? Like, what do you think?
I tend to have it's funny because like, I think when like 2013, 2014, when this first was like coming out on the scene and like cricket farmers were starting their farms and everybody's getting excited, there were like these projections that the edible insect industry would be worth however many $1 billion by 2030. And so now we're, halfway there, and people are looking and going, I don't know if we're going to hit that like billions of dollars of industry that we thought we would. And so it's scaring some people. People are like, oh, maybe we were wrong. Maybe this isn't the answer. Maybe we shouldn't be doing this. But for me, I study generations. Like, evolution is change over generational time. And so I just look at this as the most obvious thing that we need generational change for, because what we need are people that are going to put the regulations in place. Like, most of our food that we eat is produced with huge government subsidies. Like, the amount it costs for the farmer to produce it is nothing compared to what it actually costs to produce it, because there's money that the government subsidizes to them. And so we're trying to compare these tiny little, boutique cricket farms to chicken or beef that has so much government money going into it. So until government identifies crickets and insects as a food worth subsidizing, until they buy into it, it's not going to compete with that. It is a niche, boutique market right now. But every generation, like we still have boomers like in charge of everything. I'm just like, and so they are not trying to change everything to have insects. Like that is way too big of a change for what they are comfortable with. And so they're going to try to stop everything every step of the way. But as soon as we have more younger, currently younger people up there making the major decisions, like if we lay out all this groundwork, if we keep doing the life cycle analysis, right? If we keep understanding what it actually costs in terms of resources to produce insects, if we keep understanding them nutritionally, if we keep doing the cultural research, if we keep studying how to get people on board with something that's so foreign to them, like if we keep doing this research now on a small scale, then a generation from now, when people can change the government regulations, we have this groundwork to have a massive industry that can make real change. So it's slow building. Like it's not going to change overnight. And anybody who thought it would is really stupid to think that it would, because we have really strong biases against insects. Like we do. And you can try to tell people it's green, it's environmentally friendly, it's good for you. We don't make those decisions based on those things. We make decisions on convenience, on what tastes good, on what our parents did. Like we make our food decisions not based on logic, but based on food culture. And so that's why we need just people studying it so that this change can come and can possibly be the world-saving thing we need it to be in a couple of decades.
Yeah, I think that's a good point. There's a huge stigma. I know when I go to the entomological conferences, they have the cricket chips there and all the like cricket cookies, and I'll bring them back, home and give them to someone. They're like, no way am I eating crickets. So even something so simple like that, it's difficult to convince people. And it's like, how do we make that change in people's, perception?
And it is like food is such a, I wear so many hats, right? So one of the hats is that I am a food anthropologist, and it's, to me, like I get it. Like we hide crickets in tortilla chips and we hide crickets in chocolate chip cookies. But truthfully, what you just created is a bad chocolate chip cookie and a bad tortilla chip. Like we are very familiar with our corn-based tortilla chip and our just plain chocolate chip cookie. And so like we have comfort in those items. And so when you change them, you just make me mad for changing my comfort food. Like, so like, it's good. Like, yes, it's easier to get somebody to eat a cricket chip or eat a cricket cookie than it is to get them to eat a whole cricket. But what we need are new foods that are delicious, foods that people have never tried before. And then they try it and it's amazing and they want it again. That's what we need. We need more chefs. We need more food technology. We need people who are more skilled at creating new novel foods that people want to eat, and not us just shoving it into what we already have because we're very defensive of what we already have.
Yeah, I think that's a really good point. And I have to ask, have you ever ate any insects? And if so, which ones?
Yes. So the funny thing is I'm actually an incredibly picky eater. It is hilarious that this is what I study. So neophobia is, this, psychology that of anything new, you just don't want to try anything new. And it's very common in the US. And so I definitely have that pretty deep rooted in me. Because I'm stubborn though too, I can steel myself, and I've learned to eat insects because I started making a career on it. And so I do eat bugs. Here in the US, we have crickets and mealworms are both farmed. And so it's the easiest to get. I have a preference for mealworms. My favorite thing is like to make trail mixes or Chex mixes and use less peanuts and put mealworms in place of it. Is the way I eat insects the most. I'm a snacker. I also just don't eat very well. I have a lot of nutritional knowledge, and so I use that to like piecemeal to make sure I get enough nutrients, but like I don't eat 3 meals a day. I tend to just snack. So like trail mix is a big part of like how I get through the day. And so that's how I tend to eat insects and how they fit into my diet. My colleagues in the edible insect community, I would say they're more common to use like cricket powder as a protein powder and like a shake in the morning. I don't drink shakes. I need something to crunch in the morning. But that's probably the most common way that people in the community eat insects in their regular diet. So yeah, I've managed to like overcome my biases because like I get paid to, right? So like I worked really hard to do it. But every new bug is like a brand new experience. I've never had any of the like super giant, like fear factor bugs. I've never had them. I know one day I'll have to, and it's gonna be hard for me, but like I will. But what my big thing that I try to tell people is that in these sort of change, part of the reason why I really think this is a generational change is because we program disgust into our kids. So a 2-year-old will put anything in their mouth. And so it's the adults in the room that has to go, oh, don't play in the trash. Like, don't put that in your mouth. Oh, that's disgusting. And that is exactly how we form the little pathways in their little gelatinous brain that's forming. And so if we, like, that's the biggest thing I do is like, I really don't eat a ton of insects. Like I have my snacks, and usually I have my snacks because I bought the insects to have in an event, and then I use the leftovers and I snack on them till they're gone. But the biggest thing I do is that when you put that big bug in front of me that I really don't want to eat, I'm just going to still myself. I'm going to be quiet and I'm going to eat it. And I'm going to respect the culture that, that put it in front of me. I'm going to respect the people that are living today because they had this as a food source to get them through. Had it as a preferred food resource. This isn't a thing that people only eat in fallback times. This is, societies prefer insects over meat in certain places. And so those are the things that I remember when I'm trying to eat a new food. And I also remember that my reaction affects those around me, and that our society, we think it's cute to like be disgusted. Like it's not cute. You're just passing that reaction on to somebody who had no say in it. Right? Like if we keep passing this disgust on to our children, and they're going to grow up, be 30 years old and really wish they could eat bugs, but they're grossed out by it and now have to overcome it. Like we will do the younger generations a huge favor if we let their brains develop their own preferences for eating bugs instead of putting ours on them.
Yeah, that's an amazing perspective, excuse me. Especially because we tell people if a kid falls, they're going to look at you and you should stay calm and like not have a reaction, because then they'll have a reaction. So it's the same exact thought process. Yeah, I loved hearing your perspective on things. I know you touched on like no results is still results. And I was wondering if you had like any other advice for grad students or younger you that you would like to share with people going into grad school and anything else like that.
To me, like I remember being a student and thinking like, oh, I have an idea. And then you dig into the literature a little bit and you see that it's been done, right? Like there's this sort of feeling that there's nothing left to ask, right? All the important questions have been asked. And that's hard. It's part of that's just what building your knowledge of scholarship is. Like you have to dig through the literature to know more what's out there. And so having your own ideas and looking for it and finding it's already answered, like it's disheartening, but that's the process. Like that's gonna happen. But the thing I try to tell, students now going into grad school and thinking about research projects is to think about these biases that are so deep rooted in academia. So think of things through a feminist perspective. Think of things through a decolonized perspective, right? So we've been studying this land like it's ours, but like it is land that was inhabited by humans before any white people got here, right? So there's a very different ways of talking about the natural environment, one that we've conquered or one that we are a part of. And so we have a very conquering narrative to how we talk about biodiversity, about land, about nature. And so that skews our questions. And so if you get rid of that, there's all these new questions that open up, so it's the same thing. We have this very as anthropologists, but even I'm sure it permeates all fields. We have a very male-centric view. And so if you open that up to include other views, women, everything across, like any spectrum, like new questions present themselves. So that's, to me, is the, yes, understand what's there, ask questions, look in the literature, but then start challenging what we think we already know by adding new perspectives to it.
Yeah, that's great advice.
Yeah, I think that's super important to keep in mind as a grad student. It can be really difficult when you're trying to figure out your research project.
Yeah. And it's, you know, and it's getting easier. Like it's funny because in academia, like because of tenure, and like I just got tenure. So tenure is like, yay, great. Like I love the security and I will take it while it's here. But at the same time, tenure doesn't do us all the greatest favors. Basically, once you're tenured, you know, it's really hard to lose your job. And they also don't really force you to retire. So a lot of the people in academia have been doing the same thing for 40 years. And so we keep like just new knowledge is still just recapitulating old knowledge because those people are still here and are still the knowledge producers. So you kind of have to look at the young, again, this younger generations, who's coming in and challenging that old knowledge. And by identifying those people, you find that sort of like jet stream for you to ride in. Because if you go, now there are a lot of, I mean, there's a range of perspectives. Everybody's very variable in their contributions and how good they are at updating their knowledge as they've been in the field for however many years. But like, when you're looking for an advisor, look for an advisor who's not been doing the same old standard. Maybe the person who's published the most and produced the most students isn't the right advisor for you, because maybe they've been doing things the same all this time and they're just going to reproduce you to be another student like you got your degree in the 80s. So when you're trying to find your advisor, look for people that are challenging the knowledge that we have. And maybe that's the right, if you're somebody who wants to push these boundaries, the advisors are out there for you. The people who are currently pushing those boundaries exist.
Yeah, I think that's really important to think about. Thank you. Yeah, thank you so much for telling us about that. And thank you so much for being on the podcast. I want to be respectful of your time and maybe finish up here. I know you mentioned you had social media, so I'll be sure to tag that in the show notes. And I guess we can finish up here. All right. Well, thank you so much, Julie.
Yeah, thanks for having me.
It was great. Thanks.
Great. And thanks everyone for listening to Bug Talk. Bye.